Hi everyone, Nasima here. Today I'm talking about something super powerful behind your favorite apps, from TikTok to smart robots, reinforcement learning. It's the type of AI that helps TikTok figure out what to show you, not by guessing, but by learning from what you actually do. Let me give you a quick hint. If you've ever watched 2 or 3 fishing videos and suddenly your whole feed is about fishing, that's reinforcement learning doing its job. I'll walk through the full structure, so stay with me. Now, imagine you're training a dog. You want it to learn how to roll, bark, wave, or catch. You give it treats when it does the right thing and you ignore or correct when it doesn't. Eventually, it figures out what gets rewards and what doesn't, right? That's basically the idea of reinforcement learning. But instead of a dog, it's an algorithm learning what actions to take just by trial and error. It learns without anyone giving it the right answer. There's no labeled data set. It plays the game and gets feedback. Reinforcement learning is a type of machine learning where an agent interacts with an environment, takes action, and learns based on the reward or penalties it receives. So in reinforcement learning, we have some terms like agent, environment, state, action, reward, penalty, policy, and goal. Let's define them first. The agent is the learner or decision maker, like your Instagram or TikTok application. Environment is the world the agent operates in, the entire feed area from those social media applications. State is a snapshot of the current situation, like you just watched a fishing video. Action is what the agent chooses to do, like let's show them a new fishing clip. Reward is the feedback signal. If you watch it, like it, or rewatch it, that's positive, right? Penalty is when the app shows you a clip and you skip or even report it, so it's a negative message. Policy is the strategy the agent builds over time. It tells the agent what action to take in each situation, and the goal is maximizing the total reward in a long run. We can say that this learning is based on reward and penalty, not labels. It allows AI to adapt in real time, discover creative strategies, and even surprise us. It can get very smart with unlimited way of thinking, make it act like a superhuman. I don't know if you heard or not, but Google's AlphaGo AI-based game player beat the best human player in Go game few years ago using this approach. Now I want to show you how the agent takes an action and the environment responds, and how fits into something called a Markov decision process, or MDP. Let's look at how it actually works step by step. The agent observes the current state of the environment. Then it picks an action based on its current policy, basically its best guess. Then the environment responds and gives back a reward or penalty plus next state. The agent takes the feedback and updates its policy to do better next time, and then will repeat this process like a forever process. Now, you'll often see this explained with something called a Markov decision process, or MDP.
No lo sé.
I decided that you don't need to master it today, and let's just stay focused on RL in this video, but I'll break it down fully in another chapter because it's a very important concept to know when we talk about learning process in AI and robots.
That makes sense.
But I should give you a hint for now to have an idea about it. And do you remember when I said the RL loop is a cycle that never ends?
I have no idea. Okay, thanks.
So you can think of an MDP as the formal math version of this loop. States, actions, rewards, and transitions all written down neatly so we can actually analyze, compare, and even prove which strategies work best. Although without the structure, RL can still run in simulator, but it's much harder to reason about why one approach is better than the other. And MDP acts like a policy founder, a kind of rule book that helps us enhance what we learn and reuse it later, so robots or game agents can make quicker and more reliable decisions in time. So for now, just consider that Markov decision process has a very important role here. I have this important question: how much the agent explore new things vs stick to what it already knows works? There are two things: rewards and penalties. Let's go back to TikTok for a sec. If you watch a full video of fishing in a river, maybe even rewatch or share it with your friends, that's a clear reward signal for the algorithm. On the other hand, if you sweep away that video instantly or even hated that video clip and decide to report it for any reason, that's a negative reward, basically what we call a penalty. The same idea works for dating apps, which many people use nowadays. Let's say the app is trying to figure out who to show you next. If you swipe right, match and chat for hours, that's a huge reward, right? So the app will remember the features of that person and will show you people with more similar personalities or hobbies. If you ghost the match in 10 seconds, well, that counts as a penalty, right? So every sweep, every scroll, every click, that's reinforcement data. And over time, the app learns what type of profile you tend to respond to. Just like TikTok learns what kind of content you can't stop watching. Right now, TikTok agent has some idea of what works. Should it stick to fishing clips, outdoor fishing, solo fishing, or other types of fishing that I'm unaware of? Or it should try something new. You definitely want to also see a couple of funny clips between them. This is when the concept of exploration and exploitation comes into play. Exploitation means play it safe. Keep doing what's already getting good results. TikTok shows you more fishing clips, the dating app shows you more people just like your last match. Exploration means let's try something different. Maybe there's something even better out there. TikTok throws in a cooking video for you. The dating app shows you someone who's not your usual type, just to see what happens. But why does this matter? Because if the agent only exploits, it can get stuck in a local optimum. It misses out on better long-term strategies. You leave the app because it's just showing you the same type of clips. On the other side, if it explores too much, it becomes chaotic and inefficient. You're like, why should I try so hard to find clips that I like to watch? And you decide to just delete that app, right? So that's what we call the exploration and exploitation dilemma. Actually, modern reinforcement learning research spends a ton of energy trying to balance this trade-off in smarter ways. A good starting point is usually and academically 70% exploitation and 30% exploration. So 3 out of 4 decisions are intentionally risky. That's not by accident. That's designed into the system. In the early phase of learning, exploration might even go up to like 40% or more because the agent needs to test. Later, it might drop to 5 to 10% as the system stabilizes. There are algorithms that handle explore and exploit dilemma based on the situation they are into. So just remember that this balancing act is huge in modern reinforcement learning research. Too much exploration wastes time and resources. Too much exploitation traps the agent in habits that might be suboptimal. And this applies everywhere, like again, TikTok trying new content, Netflix trying new genres, YouTube music testing genres you never asked for, ad engine deciding whether to retarget you or not, a robot deciding whether to test a new move in chess or not. So next time TikTok shows you random video you've never seen before, that's not a glitch. That's intentional exploration.
And if you don't know, now you know.
The algorithm checking if your preferences are shifting. So to answer this question, that where is reinforcement learning actually used? Let me hit you with a few examples. So as we've talked about, you can see it in TikTok, Instagram, and YouTube recommendations.
What? Why do you keep doing this to us?
Yeah, I know. I keep bringing this up, but there's a real deal here. Every time you interact with a video, the system gets a reward or penalty. And based on that, it learns what kind of content to serve you next. But not just based on what you like. It is also based on what you might grow to like. That's long-term policy learning. The other example is self-learning robots. OpenAI builds a robot hand that learned to solve a Rubik's Cube. No human-coded instructions. The agent learned by trial and error and thousands of micro rewards. Another example is healthcare in some clinical trials. Reinforcement learning models help optimize treatment sequences like adjusting dosage step by step based on patients' reactions to improve outcome over time. We also have it in finance and trading. Reinforcement agents simulate thousands of market scenarios to learn trading strategies that aim to maximize return. So in short, reinforcement learning is incredibly powerful, specifically in systems where you can define a reward, actions affect the future, places like you want your agent to adapt and discover, not just follow instructions. But on the other hand, it's also resource heavy, hard to scale, and not always the right tool for every AI problem. Okay, so that was reinforcement learning. If you haven't watched my video on supervised and unsupervised learning, I definitely recommend checking them out.
Check it out. Check it out.
They give you the foundation to really understand why RL is different and why it's such a big deal in modern AI. As I promised, I also be covering more advanced stuff later like MDP. So if you're into this space, hit that like, drop a comment, and let me know what you want me to cover next. See you in the next one. Bye!